Today we're going to look at the Python for Data Analysis library. This is a somewhat complex library, but very useful for manipulating data, especially if data can be represented as tables. So in this first hour, I'm going to give a brief introduction to the library and focus on two important classes. So two types of objects that we're going to use. Classes are something like the factory for objects. So if we use the series class to create a series object, then we can use that object, and the same for DataFrame. So basically a series object can store a sequence of values with an index. So you can think of it as a dictionary, but with also ordering and position inside the dictionary. And then the data frame is a set of series that share the same index. So we can imagine the data frame as a table with each column being a series and a shared index to refer to each row on the table. So in this first lecture, I'm going to give some examples of how to use how to use pandas to operate with data tables. And the idea is not to memorize, because these are not basic elements of Python. It's to understand what you can do with it, and then when you are using this library in some practical application, you should look up the documentation, see examples and so on, and adapt to your problems. So let's start with this basic type of object, this class series. So this is an indexed array. It works somewhat similarly to dictionaries, but is also an array in the sense that has some ordering, and you can access values by position. It also can have duplicate values in the index, so it does not have that restriction the dictionary has, in which the keys cannot be repeated. We can create a series object from data in an index or a dictionary. If we create it from a dictionary, the index will be created from the keys, and then the data itself, the values, from the values associated. So let's look at an example to understand how to use these objects. Let's suppose we are fermenting wine, and there is this Brix index which estimates the proportion or the concentration of fermentable sugars in the mixture. So basically, the density of the solution is compared to water, and if it's denser than water, it has a higher Brix index because of the sugars dissolved in the solution. So we start out, we measure the Brix index in our mixture as the wine is fermenting. These values here in hours we set for the index. So the index is the number of hours after the fermentation starts, and the values associated are the Brix index. The Brix index will diminish as the fermentation progresses, and eventually, since alcohol accumulates in the solution, the solution starts to become less dense than water, and we can have negative Brix indexes at the end of the fermentation. So we measure the Brix index at given time points during the fermentation, and now we create a data series using this series class here. So the way you create an object from this class is to use the class and give the class the arguments you need to create the object. So to create this series object that we're going to refer to with this variable Brix, we will give as first argument the values we have, the Brix values we measured, and then we give as the index for the series the time, the hours at which we obtain each sample. So now this is the series. If we want to print out what the Brix series has, we have these two columns. So these are integers, the data type, and the first column is the index for all the values, and here are the associated Brix values. So we have this value at 0 hours, 23 at 20 hours, at 40 hours 20, and so on. So this is one way we can create a series object. Now, one thing that we can do with a series object is to access the values from the index. So if we want to know what was the Brix value in our solution at 40 hours, we can use bricks 40 and we get the 20 there that is associated with this timestamp. So as long as we ask for something that is present in the index, we get the corresponding value. But this is similar to what we did with dictionaries. But in addition to this, Pandas series also works as a NumPy array for broadcasting. For example, we can compare all our values with 0 and we get another data series. So this is similar to what we did with NumPy. If we compare the NumPy array with some value, we would get a NumPy array with the Boolean values. But in this case, we obtain a series. So we have the same index there and true or false values associated with the comparison of each of the values in the series. So all these bricks measurements, each of them with 0. So here we have two true values because the last ones are negative and all the others are positive. So basically, we can think of a series object as something that combines the functionalities of a dictionary for accessing elements by the index as if it were a key, but also with the NumPy arrays. We can do operations like multiplication, sum, and so on. We can compare different arrays with the same number of elements, or in this case with the same indexes. We can do all of these operations like we did with NumPy. And so, for example, suppose that we want to know at what time did we start finding negative bricks values in our fermenting mixture. So this means that alcohol was now accumulating and we had very little amount of sugar for the fermentation to continue. So we can use these two attributes from the series. The iLock attribute allows us to access elements by their position in the series, so by order in the series, instead of the index. So remember that Python starts measuring the order, the position in an array at 0. So this first one here would be at position 0. This one at position the 23 there at position 1, then the 20 at position 2, and so forth. So we can access them by the corresponding index, or if we use iLock, we can access by the position. And also we have this index attribute of the series that allows us to access the index values instead of the values themselves. So if we do this bricks less than 0, this works like we did with NumPy arrays. So this comparison here, by comparing our series bricks with 0, will give us a series with indexes and true and false values. We can use a series like this to select those indexes from some other series, or the values that correspond to true values in this Boolean series. So because the series have indexes, Pandas can use the comparison between the corresponding entries in the different series. So if we do this, bricks less than 0, we get a Boolean series with false values, except when the bricks value becomes lower than 0, and in that case we get true values. So if we select from the brick series those that have true values in this condition, we get a smaller series that only has the two elements that are below 0. So this works similar to NumPy. And now we can create a new series. For example, let's call it alcohol, which is the one with larger alcohol content. We put there only these two values that have a bricks index negative. And now we will ask for the first element in this series. So note that we don't need to know that the first element has an index of 250, because we can use iLock and access the first value in the series, regardless of its index. So the first value is -2. And we can also ask for the index of the first value. And this, we go to alcohol and ask for index 0. And here we have the 250, which is the number of hours before we noticed that the bricks value was below 0. So this is just an example of how you can use series objects in a way that is analogous to dictionaries or to NumPy arrays. So it combines the two different functionalities. But now let's put some series together into a data frame. A data frame is a table with any number of columns, and each column is a series. But it's not just a set of series because they all share the same index. So we have this notion of rows which are created by the values taken from all the series with the same index value, so the same shared index. So to create a data frame now, we're going to create a new series. We already have the bricks values for our fermentation here. Now we're going to also add the temperature measurements during fermentation. So let's suppose we measure temperature in the beginning at 50 hours, 100 and so on. So we every 50 hours we took a temperature measurement, we stored all the values here, we create a series with the index, which are also the hours when we took those measurements, and now we create a data frame. So we get the data frame class, we import the data frame class from pandas, and now we use the data frame class to create a table with two columns. One called bricks with our bricks index, and one called temperature with the measured temperatures. So to create a data frame, you can use a dictionary where the keys of the dictionary are the names of the columns. The values associated can either be series, and in that case, as long as they have be careful to put the same index on all the series. They don't need to have the same number of values or the same values in the index, but if the index means the same thing, then the table will be correctly created. Of course, if you have series that have different indexes, then the table will be meaningless. But if you use series to create a data frame, the series do not need to have all the same length. You can also create a data frame with arrays, like NumPy arrays or lists, something like that, instead of series. But in that case, because those arrays do not have an index, pandas would not know how to match the different values if the arrays were not all the same length. So if you use series, the length can be different between the number of values in the different columns. If you use arrays or lists, then they need to be all the same. But in this case, we are using series, and we have fewer data points for the temperature than we have for the bricks measurement. So this means that the number of values in the different columns will not be the same. But this is not a problem because pandas will match the corresponding indexes of the two series and will fill with an empty value or not a number those values that are missing. For example, we have bricks values for time 0, 20, 40 and 60. And we have temperature for times 0, 50 and 100. So this means that we have a value for the bricks index at 20 hours, but we don't have a temperature there, neither at 40. But then we have temperature at 50, but we don't have the bricks value for 50. So this is not a problem because they all have the same index, and pandas can match the column and fill in the gaps with these not a number. So this is something also that can happen frequently when you load data. Sometimes there are missing values in the tables, and we need to take them into account either by ignoring them. So if you use pandas to do some statistics, it will ignore the missing values. For example, when computing mean, maximum, and so on. But sometimes we may need to actually put in a value. And in that case, we have different ways of approaching this problem. So let's suppose that we want to do something for which we cannot have empty values or missing values in our data. So one possibility is to drop rows with missing values. So we don't want any row in our table that has a value missing. In this case, this is easy to do. We use this drop NA method for the data frame, and it will return a copy of the data frame, a new data frame with without the rows that have missing values. So this row with index 0 remains. the rows with the index 20, 40, and 50 are missing because they are missing a value either in the temperature or on the Brix value. Then we are also missing row with index 60. And then after 100, everything has values, so we get all the rows here. So if you need to just discard rows that have missing values, you can use this drop NA, and you get a copy of your original table without those problematic rows. Another method is to fill the missing values, either by copying from the previous non-missing values, so copying forward, and this is the F fill, forward fill, and this will, in this case, for example, we have two missing values here, but this entry has a value. So this will be copied twice, and we get 25, 25, 25 here. The same happens here, the 20 will be copied forward. We can do it in the reverse, we can copy backwards if we use the B fill. So this is the fill NA method, so to fill cells that have missing values, but we can select in the method whether to fill forward if it's F fill or to fill backwards with B fill. So in this case, what we do is we have two missing values here, but then we have this 28, so the 28 is copied backwards over the missing values. Which one you choose will depend on the data that you have, but sometimes for processing data series, time series, for example, there may be situations where one of these methods is more appropriate. If you want, you can also do interpolation. So you can use the interpolate method in table, and you have different options here for interpolation, but the one, if you use the index, the interpolation will take into account also the differences in the index. For example, between 50 and 60, there are only 10 hours of difference, but between 60 and 100, there are 40. So if Pandas needs to interpolate there, it will take into account those differences. So what this does is a linear interpolation between the extremities around any gap in the values, and then fills in the missing values with the interpolated values. Also, if you use this method with the index, also taking into account the differences between the index values. So basically, there are other ways you can fill in the missing values. You can write your own functions to fill in the values and so on. So there are many different ways you can do this. But this is just a few examples so that you know that you can easily fill in the missing values or discard the missing values depending on what you find more appropriate to do with your data. We can also create a data frame with a dictionary of lists. So in this case here, we created a data frame with a dictionary of series, the Brix series and the temp series. In this case, we don't need to have exactly the same number of elements on all the series because we have the index, and Pandas can use the index to match the different values. But we can also create a data frame with a dictionary that has as keys the name of each column, and as values a list that has the values along the column. Now in this case, since lists don't have these extra indexes to match the different values, all of these must have the same length. Otherwise, Pandas would not be able to tell which value went with which one. If we don't add an index here, then Pandas will create one by default, in this case just starting from 0 and moving onwards from there. So this is an example of stars that are close to us. So this one at distance 0 light years is the Sun. This is the magnitude observed here from the Earth, the spectral type, the second one, the distance, and so forth. And also another thing that you can see in this example is that it's not a problem to mix data that has a string format with data that is numerical. This is another good thing about Pandas, which unlike what you do with NumPy, which you should use only the matrices for uniform data. With Pandas, you don't have problem with adding data types of different data types into the same table. Okay, so now we have this table of stars. We have distance, magnitude, and spectral type, and we'll see what else we can do with this table. For example, suppose that we want to remove one column. We don't want the magnitude, so we just want the same table without magnitude. We can use this drop method where we tell which columns to drop, and if we are dropping the columns, we must also indicate that we are dropping along the axis 1. So axis 1 is the axis along the columns. So in this case, we are dropping magnitude and we get a copy of our table. Note that these operations do not change the original data set. So this original table star still has magnitude, but we get a copy with only these two columns. We can also drop rows. So in this case, we can tell the index of the row to drop, and we tell in this case, axis 0, which is along the rows, and we are dropping, in this case, the one with index 2, so this star here disappeared from the table. Note that since the stars table is always the same, when we do drop with magnitude, we get these two columns, but if now we do drop with index 2, we get the three original columns, because stars still has the three original columns. We are just generating different views of the on the table. So we can also access the elements in the table either by accessing the column. So if you want to get the values in a given column as a series from a data frame from one of these tables, you just need to specify which column you want. And we can also use the lock attribute here to specify the rows that we want with a series that has an index. So we can either specify by index or with a Boolean series that has the index and true and false values. So in this case, we get all the rows that have a true value on that series. So here we compare the distance column of the stars table. So this one here, we compare it to 100. This will give us a series that is similar to this one, but instead of having the distance values, we'll have associated with each index a true or false value, depending on whether or not it's larger than 100. So this one will be false, this one will be true, false, true. And now when we use this series as an index for selecting rows from the stars table, we get only the rows for which this is true. So we get the rows for which distance is larger than 100. So in this way, it's very easy for you to select what parts of the data frame you want, whether columns or rows, by using these Boolean masks or specifying different columns. So let's see a more practical example. There is this database of procurement data of public contracts that is base.gov. A few years ago it worked a bit differently. So last time I tried, we could only download 2,000 records at a time. Well, actually, the one before the last time. The last time I tried was in a few days ago, and I couldn't download anything. It didn't appear to be working, but I don't know if this is different now. In any case, at that time, the maximum number of records we could download was 2,000. And we could download it in CSV format. I think now you can also download it in Excel format. But so I downloaded two files. One, 2,000 records starting from January 1st, 2015, and 2,000 records starting from January 20th, 2015. So there was some overlap between the two, but I wanted to have a larger series, so I start with those two files, two blocks of 2,000 records each. Now, these records have data on government spending, so things like the type of contract, how much it was worth, the date, the person who was paid, and so forth, or the company, this kind of data. So this is the way the table looks, and this is how we can read the two files into DataFrames. So we're going to import series and data frame. You can, if you want to create your own series and data frame objects, you can do it like this. Alternatively, you can do it this way. Just import pandas. Usually we give it this nickname, PD, just like we do it with NumPy, NP, and so on. And now we can use functions from the pandas module. One useful one in this case is this read CSV function, where you specify the file name, you can specify the separator, and it will read the data into a data frame. You also have functions to read from Excel, to read from HTML tables, and so on. So in general, pandas, if you're using some kind of standard format, pandas can be very useful to get your data. The tricky thing is that you need to really have tables, one large table in your data. If you have several different tables separately, then it becomes trickier to use pandas with that. But in this case, each file was just one table, so we load it, and pandas automatically identifies the column names in the first row and creates an index and so forth. So this is what we can see here. If now we have these two temporary tables, table 1 and table 2, with the two files. If we look at the columns that are present in table 1, so this columns attribute gives you, in this case it's an index object, but it's analogous to a list with the names of the different columns. So we have this objeto de contrato, tipo procedimento, and so on. We can also join tables together using the concat function from pandas. So basically, we give the concat function a list or a tuple with all the data frames we want to concatenate, and we, by default, it will concatenate them along the rows. So it will add the rows of table 2 after the end of table 1. You can also do different types of concatenations. You can do joins, a bit like with SQL also. I'm not going to look into those, but there's a lot of more sophisticated options that you want if you need to do something more complex. In this example, we just need to put the two different files into the same table as a first step. So we use this concat function. And now we get this table variable that is referring to a data frame which has all the data we loaded. So now we have one problem here, is that there is some overlap between the two files. So I started the second one at January 20, but there were this first one goes over January 20 because the first 2,000 records end later than January 20. But we can check that easily. If you call the duplicated function or the duplicated method in a data frame, it will give you a series with a true value for all the rows that are a repetition of some previous row. So the first time it encounters a row with a certain set of values, that one is not duplicated. But if it encounters the same set of values a second time, that one will be marked as duplicated. So if we take this series with all the true and false values for all the duplicated rows, and we use this value count method, this is a very useful method because it gives you a series with the different types of values you have and how many times they occur. So since this series with the duplicated indicators, with the true and false values for the duplicates only has true and false values, this value count will give us a small series with only false and true, telling us that there are 3,632 rows in our table which were not duplicated. So these are the number of falses, and then there are 368 which were duplicated. Another way of doing this would be to get the value count series and then ask for the entry corresponding to true, so this one here, and this would tell us how many are duplicated. So this table duplicated gives us a series indicating all the rows that are duplicated with a true value, and this value count allows us to quickly count how many they are. Note that this is not something for you to memorize, but if you remember that you can do this easily, then it's easy to look up to Google and find out how to do this kind of operations. Okay, so now we have a little problem, because when we loaded the table, the first one, an index was created from 0 to 1999, the same for the second one, but then when we concatenated, even after removing the duplicates, so we can use the drop duplicates to remove all the rows that are equal to some previous row, so all the duplicates will be gone. But now if we ask for the entry corresponding to index 1100, for example, we get two different entries, because there is one entry with this index from the first file and another that came from the second file, because when the files were loaded, the indexes were created at that moment. So what we can do to get rid of that problem is to simply recompute the index. So we can call reset index. Once again, note that all of these functions, reset index, drop duplicates, and so on, they do not affect the values on the table. They give us a new table with the transformation, with the operation performed in that table. So if we want to actually keep changing our table, either we add an argument there to do the transformation in place, or we place the result of this operation back into the same variable. So that's why I'm doing this table equals to table drop duplicate, so that I replace my original table with the table without duplicates, and the same thing with the table with the index reset. Okay, so now reset index, what this does is to create an index starting at 0, going through all the rows, and now at position 1 or index 1100, I only have one entry. It's this one. I have the index value there, the contract type, and so on. Actually, this is the previous index that I had before. When you do reset index, the previous index gets added to the data frame as a new column, so you don't lose that information. But if you want, you can then drop that new column. So the price column here, you can find when you look at the preço contratual, this is what the state paid for each contract, is in a very inconvenient format. So instead of being a number, which would be most convenient for computing extremities, maximum, minimum, averages, and so on, what they did is to store there a string that has this euro sign here, it has a space, it has a point separating the thousands place, and then has a comma for the decimal point. So we cannot easily convert this into a floating point number. We need to process these strings and get rid of all these extra characters in order to convert this into a number. But this is also easy to do with pandas. You can create a function that will do whatever operation you want done on the cells of a table. So in this case, we want to convert the euros field there. We get as a text one of these strings. This is what the value that is in a cell. And what we do is we split on the space to get the first part. So basically, it's the space is here. This would be the first part on this side with index 0. We extract this part from the text. Now we replace the point there, the period mark, that was just marking the thousands. We replace this with nothing, so that we delete these period marks here. So it will be, the numbers will be like this. Also, we remove this part, so it's we are looking at the string like this. And now we replace the comma with a period, so that we can convert this into float. And this we do here. We replace the comma with a period mark, and then we return the result of converting that remaining string with just a number into a floating point number. Okay, and now we have the function that can solve our problem for one cell. And what we do is we say that we want to store in this column of our table with the price, the result of taking the column and applying this function to all its cells. So we use the apply method of the series in this case, and what pandas will do will, for each cell in this series, so for each value here, it will feed it into our function and replace it with the result of our function. So this will give us a new series that has all the values replaced into floating point values, and then we store this back into our table so that we replace the data here. Remember that this apply, unless you add some specific arguments there, will not change the original data. We'll just give you a copy. So this is a general way of pandas working, and if you really want to throw away the previous data, then you can do so explicitly like this, or adding there an argument to do it in place in the same table. Okay, so now we have the price converted into numbers, and now we can ask for some statistics. So data series in pandas have these methods to get the maximum, the average, the median, the minimum, and so on. So it's easy to find what is the maximum, minimum, median, or mean of the price. And one thing that we can see here that is a bit strange is that the minimum value is 0. So it seems that there were some acquisitions that were for free. They have no euros there. And we can do this. We can create a mask for finding which ones have 0. So basically this is a series with Boolean values, true or false, that is true for all the indexes corresponding to table to the price being equal to 0. We could also just we could use this to select the tables. We could do it directly like this, but sometimes it's better to simplify a bit your expressions. So in this case, I created a variable just to get the series that tells me which ones are the rows of interest, so the rows where the price is 0, and I can even compute how many they are by adding all the values. So when you add Boolean values like this in this series, false counts as 0 and true counts as 1. So the sum of a series of Boolean values will give you how many true values you have there. So we can see immediately that there are 9 cases where the price is 0, and we can also ask from the table which cases in our table have a price 0. So this is the new index. The first values here is the new index that we created with reset index. This index column here was created when we reset the index to store the original index. So remember that we loaded this into 2 files. So this would be from the first file going all the way to 2000, and this would be from the second file starting again at 0 and going up again. But we have this all in the same table. This is the index we're using now, and now we can see the contract object and all the different fields. So I cut this out a bit because the table is rather large, but we can extract from our table those intriguing examples of a 0 price. Okay, so let's look at another example of manipulating data. We have this database with the different stars surrounding our solar system. So it includes the sun here at our solar system, and then we have different stars at different positions in the sky, and also different magnitudes, distances, and so on, spectral types, and so forth. So to load this, in this case, this is also CSV. We can use CSV for loading the data frame, and now we can get the first 5 or the 5 most common spectral types in our database. So these are the different spectral types, K0, G5, and so forth. We have this in the spect column on the file. So we cannot, it's here. So this column has the spectral type. And if we use the value counts method, we saw it previously, we get a sorted series that has each unique value in the series that we are starting from. So in this case, we are looking at the values in this, the spectral, in the column of the spectral type, the spect column. And we get for each unique value, that value as the index and as the associated value, how many times it occurs. So this tells us that the K0 spectral type is occurring 8,500 times in our table, the G5 6,000 times, A0 4,900 times, and so forth. So we have these counts of how many times each value occurs in this column. Of course, this would be very long. It could be very long because it will have as many entries as unique values we have in that series, but we can cut it to the first 5 elements, for example. So we want just the first 5, which are the 5 most common. And this tells us which are the 5 most common and how many times they occur in our table. So let's see just another example for trying to understand data or looking at the data, summarizing the table. And in this case, I'm going to use yet another database. This is data from these river people, these Native American people from Arizona, and they have this particularity that this ethnic group has among the highest incidence of type 2 diabetes in the world. So this is probably due to recent changes in diet from their original diet and now with industrialization and so on. So this database is a sample of 768 women with age 21 or more, and it has some indicators like the number of times they were pregnant, glucose plasma concentration, blood pressure, body mass index, age, and so forth. So we have 8 clinical indicators here, and there is one class variable also in our data set. So this is 1 if diabetic or 0 if non-diabetic. Now I'm using this example. One of the reasons is because the data file that we have is just has the values. So they are separated by commas. We can read it as a CSV file, but it doesn't have the column headings. So we need to include the column headings when we read into a data frame. So we can do it like this. We're going to use the pandas library. We're going to use the read CSV function to read from the file into a data frame. And since our file does not have column names, we need to create a list of names to put in as the column names. So we're going to use these 3-letter codes for the different indicators in order. So number of times pregnant, plasma glucose concentration, diastolic blood pressure, and so on. We have these for the headings, for the column names. And the last one is 0 or 1 for diabetes. And now we can read from the file. So we read from this CSV file and we add this additional argument, which has a list with the names of the columns. So now we can get a description of our table. We can use describe to print out what our data looks like. And this is a very useful function because we get a short table with just the summary of the data. How many values we have that are actual values, so not missing values. We can see that we have values for all the rows, all 768 of them. What is the mean of each column? What is the standard deviation, the minimum, the quantiles, the maximum, and so on. So describe gives you a summary of the data and can be very useful when you start examining what data you have. In this case, even though we don't have missing values, we have a problem with missing values because we have some zeros in our data that should not be there. For example, if you look here, the minimum value for number of times pregnant is 0. So this is realistic because maybe this woman was never pregnant. But the plasma glucose concentration cannot be 0. and the diastolic blood pressure cannot be 0. So there are indicators here that would not be possible to be 0. So we can suspect that missing data in this case was marked with a 0. We don't know, we cannot identify that in some of the columns. For example, number of times pregnant, we cannot tell if a 0 is missing data or an actual value, but we can tell that for plasma glucose concentration or blood pressure and so on, 0 is impossible. So let's consider these columns 2 through 6, which cannot have 0 as a value, and we need to mark zeros there as missing values. So what we can do is we can use the iLock method of the data frame to access the data by indexing the same way we would a rectangular matrix in NumPy. So by the order of the columns and the order of the rows. So we can do this from our data. We are going to get all the rows and columns 1 through 6. Now we're going to, so columns 2 through 6, sorry, because remember that indexing starts at 1, so first column will be index 0. And here we're going to replace all the zeros with not a number. This is the way we're going to use to identify missing values in our table. And then we're going to try again and do describe. So we're going to copy into our table all the rows, columns of index 1 through 6. We're going to copy the result of replacing the data there, replacing all the zeros with not a number. Now we can describe again, and we have something that is a bit more reasonable. We have the minimum values for these. Note that age cannot have 0 also, but age actually doesn't have any zeros there, so we don't have problems with that particular column, but all the others now are fixed. And now we can see here in the count that we lost quite a few values. For example, for blood pressure, we came down from 768 to 733. So there were quite a few women for which blood pressure was not measured. And then there are these other indicators, which I don't remember what they are. So this serum insulin concentration, for example, you have here that we have about half of them don't have serum insulin concentration measurement. So we cannot, we don't have those values in our data. So this is what happened when we replaced the 0 with not a number. So to sum up this part, the pandas library has these two very useful classes, series and data frames, and they allow us to, in the series, allows us to create a series of data which has indexes and corresponding values, and the data frame allows us to put together a series, a set of series, all with the same indexes into one table. This allows us to use heterogeneous data because we can put together strings and numbers and different types of values in the same table. And it has these functionalities for dealing with missing values, for selecting parts of the table, for summarizing data, and so forth. So when you're actually using this in practice, look up the documentation because this is not something that you can memorize, but as you get a bit more practice with this, it becomes easier. And also, if you get into the habit of looking up examples and the documentation for the different functions, this becomes very easy to use and can save you a lot of time and work when dealing with tabular data. Okay, so let's take a 10-minute break. We'll continue at 6 with the visualization part.